actually do it, right? Because otherwise, when you see the diagram complete, it doesn't many a times make much sense, and then you'll have to mug it up. Now you see this diagram. The ability of a ship to withstand the combined effects of beam, wind, and rolling shall be demonstrated as follows. We have the curve for the leeward side, curve for the windward side, right? A ship is subjected to a steady wind pressure acting perpendicular to the ship's center line, which results in a steady wind heeling lever LW1. So that's LW1. This steady wind heeling lever LW1 is to be calculated by the formula PAZ upon 1000 into G into displacement, where all these three are explained. Now the angle, the heel caused because of the steady wind phi 0, this shall not be greater than 16 degrees or 80% of angle of deck immersion. Now, from this condition, the vessel rolls into the wind, that is to the windward, under the action of the wave. From the resultant angle of equilibrium phi 0, the ship is assumed to roll owing to wave action to an angle of roll of phi 1 to the windward. Okay. The formula for the calculating phi 1 is based on formulae and tables contained in the Code of Intact Stability. The ship is then subjected to, immediately as the wave puts her into the wind, the ship is subjected to a gust wind pressure, which results in a wind lever LW2. And convention code wants LW2 to be taken as 1.5 times of LW1. So now we mark LW2 on the diagram. Under these circumstances, which we have done, area B shall not be less than the area A, or B shall be greater than or equal to A, whatever you want to say. What is area A? This is area A. What is area B? This is area B. Area B is calculated up to what angle? It is calculated up to angle phi 2. And what is phi 2? Phi 2 is least of the three values. One is angle of down flooding, other is 50 degrees, and the last is the second intercept of LW2 with the writing arm curve, that is phi C. Whichever is the least of the three, that defines the right boundary of area B. And that completes your explanation of severe wind and rolling criteria, or wind and weather criteria. Just take you through the intact stability requirement as per Code of Intact Stability, which you have done in phase 1, which is on page 5 of your MV in ship stability booklet. The area under the GZ curve shall not be less than 0.055 meter radian up to 30 degrees angle of heel. The area under the GZ curve shall not be less than 0.09 meter radian up to 40 degrees or angle of down flooding, whichever is lesser. The area under the writing lever curve between the angle of 30 degrees and 40 or down flooding, whichever is lesser, shall not be less than 0.03 meter radian. The writing lever shall be not less than 0.2 meters at an angle of heel equal to or greater than 30 degrees. So they don't want suddenly that up to 30 degrees it goes up and then suddenly dips down. So they want to make sure that at 30 degrees or a higher angle, the minimum GZ should be at least 0.2 meters. The maximum writing lever shall occur at an angle of heel of not less than 25 degrees. Then, of course, if it's not practicable, then it's the discretion of the administration which comes in. And then the initial metacentric height shall not be less than 0.15 meters. This is the criteria which you have learned. So you should not be surprised if these things are again asked in phase 2 also. What gets added to it is shall comply with the requirements of severe wind and rolling criteria or the weather criteria. And it is the last point here that is under discussion today. Right, guys? Okay. Now, before we start discussing this topic, let's first understand how we make the diagram. Okay. Now, first, all of you are familiar with the GZ curve, typical GZ curve of a stable upright ship. So, angle of heel is on the x-axis, lever is on the y-axis, and I'm sure all of you are agree that the GZ curve looks something somewhat like this. Correct, beta?
Yes, sir.
Yes, sir. Okay. Now, if this is the GZ curve for one side, whichever side it is, we usually say this is for the windward side. Okay. Anyway, it is for one side. The other side can be either made here like this. Now, in this, what is happening is the lever is positive over the x-axis for this green curve and negative below the x-axis. For the opposite side, one way is I can make it here like this. Then for this red one, this is positive and this is negative. Agreed, guys? What have I done? I have drawn the GZ curve for both the sides. Yes or no? Correct? Agreed?
Yes, sir.
For this concept, this opposite side one will vertically flip and bring to the third quadrant. So I'm just telling you how the diagram is actually drawn. Understood, guys? And now this red axis is positive for this one. For this diagram, this is positive, and above the x-axis is negative for the red one. For the green one, this is positive, this is negative. For the red one, this is positive and this is negative. Okay, guys, it has only been flipped to the third thing, but these are the GZ diagrams of the same ship on the two sides. Have you understood how this diagram has been achieved until now, beta? Same diagram is here now. I have removed all the unnecessary stuff from here. Now, what is the objective of this criteria? The objective of this criteria is the ability to ensure the ability of a ship to withstand combined effect of beam wind and rolling. So that is the objective of this entire criteria. How do we demonstrate it? We'll demonstrate first for them demonstrating or establishing compliance. We'll make this diagram that has been explained to you how the diagram has come. Okay. Now we shall assume that the wind, now this GZ curve is for the leeward side and this GZ curve is for the windward side. It's not written on the diagram. So in the next sheet, I'll remove all that. It's only for explanation. So one side is for the leeward, the other side is for the windward. Now, the ship is subjected to a steady wind pressure acting perpendicular to the ship's center line, which results in a steady wind heeling lever LW1. What does it mean? That, for example, so now here, let us say I have the ship. GZ for this side is here. GZ for the other side is in the third quadrant. He says the wind is subjected to a steady wind pressure beam on this side. When it is like this, let us say in this case, this is the port and starboard. So port side becomes the windward side and starboard side becomes the lee side. So this is the lee side now. Okay. Now the ship is subjected to a steady wind pressure. What will the wind do? It will act on the windage area of the ship and it will cause a wind heeling movement. Yes or no, beta? Correct? Correct?
Yes.
And this wind heeling moment will have a lever. Okay. Guys, if you remember question number 87 of your MV Hinship, GZ curve, those of you might be fresh with the memory. In that, the question read like this. The vessel experiences a steady upsetting moment of 4,500 ton meter. Yes or no? Correct, beta?
Yes, sir.
Find the list or heel cost. Okay, उसमें हमने क्या किया था? हमने 4,500 ton meter को we divided by displacement and we got, if you have the book, you can go to question number 87 as I'm speaking. There we said we divided the 4,500 ton meter with the displacement of the ship and we got the upsetting lever. And since
Yes.
the upsetting moment was constant, what did we do? We shifted the x-axis by that much amount and we drew the healing arm curve. In that question, if you remember, we drew the healing arm curve like this. You remember, guys? Yes or no?
Yes, sir. Remember, sir.
Exactly like that. There, the value 4,500 ton was given. Here, the value has to be calculated. That's a separate issue. But here also, there is a steady. You see the words steady wind pressure. Steady wind pressure will cause steady. Use this, write whatever is there. Whatever is on my slides is what you can write. It will make sense and you will be able to connect the dots. Okay. Now, this LW1 causes the vessel to heel, and you know where, how to find that angle. And that angle in this topic is named as phi 0. So that means the steady wind pressure causing the wind heeling lever LW1 results into a resultant angle of heel phi 0, which side? To the leeward. So this angle, I'm sure you'll agree, is phi 0. Yes or no, guys? Correct?
Yes, sir.
Correct.
No, sir, not understood.
What is it that you've not understood? Have you opened question number 87, beta, of GZ curves?
Yes, sir.
So how did you do that question number 87? This phi 0 shall not be greater than 16 degrees or 80% of angle of deck immersion. So if the vessel's phi 0 exceeds 16 degrees or vessel's 80% of the angle of deck immersion, whichever is lesser, then the vessel is failing to meet this first criteria of the severe wind and rolling.
Sir,
First, yeah,
80% of angle of deck edge immersion.
yeah. So whatever is the deck immersion at whatever angle of heel, the deck will immerse, na
Oh,
beta?
okay. 80% of that, it should not exceed 80% of that. Okay.
Yeah. So if the deck edge is going to immerse at 20 degrees, then 80% will be 16 degrees.
Yes, yes,
If it is
understood.
going to immerse at 30 degrees, then 80% will be 24 degrees, right?
Yes, yes, yes. Whichever is less. Okay.
Correct. Okay. So if the vessel does not meet this criteria, then she is failing on it. Changes have to be made for the vessel to make compliant. So is this part clear? The steady wind heel. So I'll clear this and represent this here so that there are no markings on it. The steady wind pressure causing the wind, not wing, wind heeling lever results into a resultant angle of equilibrium of phi 0 to the leeward, and obviously it is leeward side is to the right in our diagram. So this is phi 0. Angle of heel under the action of steady wind phi 0 should not exceed 16 degrees or 80% of angle of deck immersion. That is what is important to know. If it is exceeding these limits, the vessel is failing on this criteria itself. Is that clear, beta? Clear?
Yes, I got
Yes,
it.
sir.
Okay. Now, just for the sake of understanding, whatever will be in the slides will be good enough for you to present it. Okay. Guys, now the ship, let us say ship goes to 10 degrees this side. Okay. When ship goes to 10 degrees, what has happened? The work done by the steady wind will be stored into the ship as its dynamical stability, yes or no? Will be stored as the work done on the ship to heal, correct? Correct?
Yes, sir.
Right? Because when you heal the ship, when the wind heals the ship to, let us say, 10 degrees in our example, the work done by the wind to heal the ship to 10 degrees will be stored into the vessel as a dynamical stability, right, beta? That will be the dynamical stability, and that will be the work done, and that energy is stored into the vessel. Yes or no? Correct? Correct?
Correct.
Now, so there is already energy stored when the vessel is heeled to 50 on the lee side. Now the next, they are saying, while the vessel was, so in this case, let me talk of port and starboard. Code does not talk of port and starboard. They will talk of windward and leeward. Okay, I'm talking port and starboard. In my case, this is the lee side and this is the windward side. Okay. Okay. The vessel is now, let us say, heeled 10 degrees to starboard. 10 is just an example, guys. Okay. Now, while she is lying 10 degrees heeled to starboard, she is hit by a wave from the starboard side. And what does the wave do? The wave will pushes it beyond 0 degrees. Wave is only one impact. So let us say it heels are more than 10 degrees. On which side? The opposite side, into the wind. So what will happen? The vessel had some energy stored into it because of heel to starboard, which the wind was causing on it. But that has now been, more work has been done by what? By the wave to first counter that energy and maybe heal her to 15 degrees, total 15 degrees. That means now these are examples. Before I show you the slides, she take 15, the wave hits from the ship from this side and inclines her through 15 degrees. That means when it inclines through 15 degrees, or let us say 25 degrees, what does it mean? That means now the vessel is heeled 15 degrees to port. Yes or no? Because 10 degrees has been cut off from the starboard side and 15 degrees now she goes to port. Yes or no? Correct? So she has gone from this angle to this angle under the effect of wave. Which side has the wave hit from? From the lee side. Okay. Yeah. So what has happened now? There is already, the wave has done work on it to heal from starboard 10 degrees to 15 degrees on port side. That much is the work done by the wave to heal her. And whatever is the work done by the wave now has got stored into the ship as its energy. That energy corresponds to her heel from 10 degrees starboard to 15 degrees port. That means a heel through 25 degrees. Wind is still there. Now they are saying, as the vessel reaches this limit. So first let's talk about this one now. That means the vessel is now excited by the wave. So we say the vessel is, see now, vessel is heeled to 5 degrees to lee side. Now this is what you need to write. From the resultant angle of equilibrium phi 0, which is there on the diagram, the ship is assumed to roll to wave action to an angle of roll phi 1 to port side. That means now from this condition, under the effect of wave action, the ship rolls through phi 1 to the into the wind, into the windward. Understood, guys? What is he saying? This is phi 1 and this is what it goes under the action of the wave. Is that clear, beta? Wave has basically, wave from the lee side causes the vessel to roll from her earlier equilibrium condition of phi 0 now through phi 1. It's not phi 1 to port, it's total phi 1 from here. Is that clear, beta? Correct?
Correct. So in that example, this phi 1 is 25 degrees basically.
Yes, in our example, phi 1 was 25 degrees. You're absolutely right. Correct. Understood, guys? Now, for calculating LW1, we had a formula. For phi 0, there was a limit. How is this phi 1 calculated? Okay. The angle of roll phi 1 is calculated using certain formulae and some constants. The formula you need not remember. If you want to just say phi1 is for a ship is calculated using the formulae and the tables given in the code of intact stability. If you want to remember them, it's up to you. It's your choice. I have tried to simplify as much as I could so that you don't have to remember. But even if what is written in the second point is causing concern, you can say, because ultimately you should know from where is phi1 come. Phi1 will come out of some calculations, right? For the ship. So the angle phi1 is calculated using the formulae and the tables given in the code of intact stability. Is that clear, beta?